In this lecture, I'll introduce the text functions of bada. When text is drawn on the screen, the font is the essential property. In bada, the font is implemented as an independent class. You can get a font by creating a font class and constructing the object with a style and size. By setting the font of the canvas and drawing text using the canvas, you can output text in that font on the screen. You can specify the font name, style, and size when a font is constructed. You can also get the supported font names in a list by calling the System Font List N function of the font class and select one of the fonts in the list. Plain, italic, and bold styles are also supported. Multiple styles can be applied at the same time through the bitwise OR operation. You can set the font size by specifying points. In addition, you can set the character space, strikeout, and underline properties of the font. The font class also provides functions to get the font metric, such as the left-right bar, ascender, descender, and max width height. This example shows you how to construct a font and draw text on the screen using the constructed font. A font is constructed by specifying the style and size. By setting the underline property of the font is changed to an underlined font. Then, the font is set to the canvas. Now, we can display text on the screen using the constructed font. As we saw earlier, while the text function displays simple text on the screen, enriched text supports a layout. Enriched text enables the display of text with a layout by specifying properties such as vertical alignment, horizontal alignment, text wrapping, line spacing, and text abbreviation items. In the enriched text function, you can use a combination of text element objects to change the text, such as foreground color, background color, and font. Here's an example of enriched text. As you can see, to use enriched text, you have to create and construct an enriched text object. Then, I specified the horizontal alignment, vertical alignment, text wrap style, and text abbreviation enabled properties. After that, we have to add text elements to the enriched text. First, a test string element is necessary, and then we can specify the color and font. I've created a few elements with different colors. When you add these text elements to the enriched text and draw the test on the screen, you can see the following result. As you see here, the text string is aligned as specified, and the part of the text string that extends beyond the boundary is cut off. Now I'm going to explain the bada raster buffer. In general, the buffer is implemented as a C array. Each element of the array stores the color value of the corresponding pixel. The pixel color values are stored in the array in the scan line order. That is, the pixels are stored from the top left to the top right, and then the pixels are stored from the leftmost pixel of the next row to the right in sequence. Generally, the buffer in bada uses the ARGB Quad 8 buffer format. So for each pixel, the ARGB values are saved in the 8-bit unsigned character format. Depending on the situation, the encoded stream can be directly stored in the buffer. For example, the bada JPEG stream can be directly stored in the buffer. The buffer info class contains information about the buffer. In particular, the class contains information about the buffer of a canvas or the buffer of a bitmap image. This information includes the bit per pixel that describes how many bits have been used for a pixel, the pixel format that describes the format of the pixel values, the width and height of a buffer, the pointer to an array where the actual buffer is stored, as well as the pitch that describes how many bytes have been used for a scan line. A bitmap commonly refers to a raster image. In bada, a bitmap image can be created in the following ways. A bitmap image can be created by copying a part of another bitmap image. A bitmap image can be created by copying a part of a canvas. A bitmap image can also be created by converting the byte buffer data into a bitmap, or an image file can be decoded to a bitmap image by using the OSP media image class. Or you can create an empty bitmap image. The most common way of creating a bitmap image would be drawing a bitmap image on the screen using the canvas. The canvas can be used to rotate, enlarge, or shrink a bitmap image. You can get the information of a bitmap image through the buffer info class I mentioned earlier by locking the bitmap image. The canvas provides the following bitmap drawing functions: a function to draw a bitmap image specifying the position on the screen, a function to scale a bitmap, and functions to rotate or flip a bitmap image. This example shows how to create a bitmap from a canvas and draw the bitmap using the canvas. I drew objects on the screen using various functions, created a bitmap by specifying the canvas and canvas area, and then drew the bitmap on the screen at the defined position and size. As a result, you can see the effect of capturing a part of the screen and drawing it on the screen. This example reads an image file and converts the image to a bitmap. As you can see here, this example decodes the image file from the resource folder, converts it into a bitmap, and draws the image on the screen. This is the result of the example shown on the previous slide. Bada provides a 9-patched image that's widely used in user interfaces. A 9-patched image consists of 9 subsections. Some of the sections are scalable and some are not. This type of image is generally used for buttons with an image background. As you can see in this figure, the gray part of the image is the part that's scaled when the image is enlarged or shrunk. The other bright parts are the parts that are not scaled, even if the image is enlarged or shrunk. The shape of the edges of these parts remain the same, so that the outline of the image can be maintained. In this lecture, I've introduced the bada graphics functions. The canvas allows you to draw objects on the controls and provides various geometric primitives. In addition, I also introduced the functions to display text on the screen and bitmap functions.